Hello students, moving forward with chapter 4 linear equation in two variables, we will discuss about equation of lines parallel to the x and y axis. But before going to lines parallel to the x and y axis, let's find out equations for lines equation for the x axis and y axis. So to start with, ignore this question for now. To start with, if you have a real number, any real number, let's say which is in the form of coordinates, let's say 2, 0, 3, 0, minus 5, 0. So 2, 3, minus 5, they are all real numbers. 0 is also a real number. Now have you ever noticed where do these points lie? They are all going to lie on x axis. They lie on the x axis, and also any point on the x axis, the y coordinate is 0, which you can see from here, right? So these points are lying on the x axis and the y coordinate is 0. So therefore, using this, can you just assume or find out what is the equation of line on the x axis? Obviously the y coordinate is 0, so the equation of line of x axis is y is equal to 0, and equation of the y axis is x is equal to 0. Why? Because let's take examples where the x coordinate is 0. So I have 0, 8, 0, minus 9, 0, 2. So all these points, all these coordinates, the x coordinate is 0, and these points are all going to lie on my y axis. So the equation of my y axis is x is equal to 0, and equation of my x axis is y is equal to 0. So pretty simple to remember, right? For x it is y, and for y it is x is equal to 0. I'm sorry, for x it is y is equal to 0, and for y it is x is equal to 0, right? So we have now understood what are the equations of the x axis and y axis. Now let us look for equations parallel to the x axis and y axis. Let's say I have a graph over here and I'm just drawing a line parallel to my y-axis, or I'm not going to disturb this, or rather I'll just do it here. Okay, so this is my line. I'll just do it more dark. So this line is parallel to my y-axis. So let's see the coordinates. Suppose if I take a coordinate here, I take a coordinate here, I take a coordinate here and here, as well as here, here. What are my coordinates going to be? If you see, it is 3, 0. This is 3, 4, 3, 3, 3, 2, 3, 1. Similarly, I have 3, minus 1. So what is not changing over here? See my x coordinate, it is not changing anywhere. So for equation of lines parallel to your y axis, your x coordinate is going to be constant. Let me write this for you. For equations parallel to y axis, x coordinate is constant. Okay, here we have an example 3, 4, 3, 3, 3, 2, 3, 1, 3, minus 1. Similarly, now also similarly, so first of all we can represent this as some constant k and this as a y coordinate. So your y coordinate, this will be varying and this coordinate will remain a constant. Similarly, for equations parallel to the x axis, for equations parallel to the x axis, y coordinate is a constant. Okay, so I hope you got a picture of equations of line, just the coordinates that we will be having for lines parallel to the x and y axis. Now we will see for certain examples. First of all, if you have an equation x minus 2 is equal to 0. This is an equation in one variable because we have just one variable x. So this can be written as x is equal to 2. So x is equal to 2. Obviously, if you want to plot this point, this is a linear equation. If I am using this equation as a linear equation one variable, I can represent x on a number line, and this solution is unique, that is x will always be 2. So if suppose this is my number line, let's say 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4 and so on. So this line is going to extend indefinitely in both the directions. So x is equal to 2, x is here. So linear equations in one variable, they are just going to have one unique solution which can be plotted on a number line. But how about I express this equation as a linear equation in two variables? I can write this as x plus 0 into y minus 2 is equal to 0, right? So this will be x plus 0 into y is equal to 2. Now we will have infinite solution. So I'll draw my table first. With y first and x later. Now usually we take the value x as the variable here and y as the dependent value, but if you notice we already have x as the value of x as constant. So this is we know that this is going to represent my line parallel to the y axis, therefore I am taking y as the variable and x dependent on the value of y. So let's take different values of y. Let's say 0, 1, 2, minus 1, minus 2. Okay, so if I substitute it over here, what do I get? X plus, let's say if I am taking y as 0, 0 into 0 is going to give me 0, so x is going to be 2. How about 0 into 1 is going to give me 0, so x is going to be 2. Again, 2 into 0 into 2 is going to give me 0, so x is going to be 2. So x is always going to be 2. So we have indefinitely many coordinates or indefinitely many solutions for equations such as this, right? So the coordinates here are 2, 0, 2, 1, 2, 2, 2, minus 1, 2, minus 2. So for any value of y, let's say r, our coordinate is going to be of this form. So I do not really need these coordinates to mark my to draw the equation of my line. I just need to take x as my coordinate, 2 as my coordinate on the x axis and draw a line parallel to the y axis. So this is my line and I am going to mark it as x is equal to 2, or you can also represent it as x plus 0 into y is equal to 2, right? And therefore your points are these. You can mark your coordinates simply. So my coordinates here are 2, first of all this one is 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. Similarly, I have 2, minus 1, 2, minus 2, 2, minus 3, 2, minus 4. So for equations of lines parallel to my y axis, the value of my x coordinate is going to be the same, constant throughout, and for equations of lines similarly for lines parallel to my x axis, the y coordinate is going to be constant throughout, okay, and the value of the x coordinate will keep fluctuating. So we have learnt about lines parallel to the equation of lines parallel to the x-axis and y-axis. Also we have learned the equation of x-axis and y-axis. Now let's proceed with the solved example on page 76. Before we proceed, I'll erase this section. Let's read our question. Solve the equation 2x plus 1 is equal to x minus 3 and represent the solution on a number line and Cartesian plane. So first of all, we need to simplify our equation. Let us do that. I have 2x plus 1 is equal to x minus 3. I'll bring like terms on one side. So 2x minus x is equal to minus 3 minus 1. Therefore, x is equal to minus 4. So now here we have x is equal to minus 4. This is a linear equation in one variable also, if you notice. Now representing this on a number line, let's say this is my number line. I have 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, and the line will extend indefinitely in both the directions, but x is what? Minus 4. So this is x is equal to minus 4. My x is here. So we have represented this equation on the number line. Now how about representing this equation on the Cartesian plane? So in order to first of all, what should we do to this equation so that we get an equation for line in the Cartesian plane? We need an equation in two variables. So how are we going to do that? Let's say this is x is equal to minus 4. I can rewrite this as x plus 0 into y is equal to minus 4. Correct? Also, by looking at itself, what do we notice? That the x coordinate is always going to be a constant. So this is a line parallel to my y-axis, but we have understood this. However, for solving our question, we need to draw a table. So while drawing the table, since I already have my value of x, first I am going to take my value of y and deduce the value for x. So y here and x. So if suppose I say 0, 1, 2, minus 1, minus 2. So these coordinates are enough, y coordinates are enough. So let's check when this variable, okay, this term, sorry. So when y is 0, x, it would be 0 into 0. So x plus 0 is minus 4. Therefore, x is minus 4. How about this one? That is y is equal to 1. I get this term as 0 again. So x is minus 4. If I take y as 2, again this entire term is 0. Therefore, x is minus 4. So you will notice that the value of my x is always minus 4. So what I am going to do is simply go ahead, take x as minus 4 on the x-axis and draw a line parallel to my y-axis and plot these points. So this is my line, x is equal to minus 4 or x plus 0y is equal to minus 4. And obviously, let's mark our coordinates. I have so this is minus 4 comma 1, minus 4 comma 2, let's say minus 4 comma 3, then this is 0 comma minus 4, sorry, minus 4 comma 0, this is minus 4 comma minus 1, minus 4 comma minus 2. So you will see that this line is going to be also, this line parallel to my y-axis is always going to be equidistant from my y-axis. So this was the solve example. We'll take a look at exercise 4.5 in the next class, which is based on equation of lines parallel to the x-axis and y-axis. We'll also have to draw number lines representing plot points on the number line for equations in one variable. So let's see that in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.